Hey everybody, how's it going? Um, it's good to finally be back in front of you. Weird, but good. I hope you are doing well. I hope you and your family are healthy and that you're had enough of 3 weeks sitting around without much to do, that you're eager and anxious to get back at some learning. So, um, I want to take a little bit of time just to go through how I envision physics happening for you. And this won't be necessarily comprehensive. Things are going to probably evolve and change as we go, as I learn more things and things that work and things that don't work so well. Um, I want to first of all go to my Schoology page, which I think you'll see here in front of you. Um, there's a new term 3 calendar. You can go there. I'm not going to click that. You can go there and list this week, what we're doing day by day. But if you go under this first folder, distance learning, for April 7th through the 10th, you'll see kind of what I have laid out for us. I want you to make sure you read this online physics, how things might work. I'm going to open it now, but I'm not going to necessarily read everything for you because that wouldn't make sense for you to read it then. But just a little welcome back paragraph by me. This is what I am anticipating, that every day there will be a folder day by day that you would click on whenever you decide to do physics. There are hours, as you can see down here on the schedule, but if you want to go do physics in the evening, that's fine because of your schedule, whatever that happens to be. But every day there will be a folder. It'll list the objectives for the day. First of all, you'll take attendance for the day, some objectives, new content, links if there's any video links or test links or web pages that I want you to go to, simulating labs or whatever we end up doing. The homework assignment for that day will be there. There will be an embedded code to join virtual office hours. If you look down here, the last half an hour of each class period, you got an email that mentioned that there are going to be class periods, not that you have to take the class at that time, but just to provide a little structure. The last half hour of those block periods, I am going to have a Google Hangout, Google Meet, if you will, called Virtual Office Hours, and you are welcome to come and ask questions. I have an electronic smartboard tablet that I could show sample calculations or solve problems for you, whatever. So feel free to join any of those office hours, preferably yours, but if it doesn't work out, it doesn't work out. But the last half hour of each class period will be for virtual office hours. There will be, on each day folder, there will be the embedded code to get to that Google Hangout or Google Meet for that particular day. You also can text me if you have questions anytime between 9:30 and 3:30. And if it doesn't fit to meet those office hours, just text me at this number here, and or you can call too, but text might be easier, and we can set up a different time if that between 9:30 and 3:30 if that works out better for you. So yeah, that's pretty much that first basics of how things might work. Then I want to show you there's next three folders are for those of you that have any missing work from weeks 1 through 7 of term 3. If you have a missing test or two, if you have a missing lab or more, specifically experiments 11, 12, and 13, the most recent ones that we did prior to our getting shut down. There is a 4th lab in that sequence called the pressure lab. I am not going to be collecting that. A good chunk of you have, but there's also a really good chunk of you that hadn't turned it in. So I'm just going to waive that one. That one's not going to be turned in. I apologize for those of you that had turned it in already, but hopefully it wasn't for naught. But so missing labs, and there's directions on how to submit those. Homework for those of you that either have to make up a test from previous chapter 5 or 6 and 7, whatever, and how you can submit that homework so you can get credit for that. And it's the same process for how you'll be submitting homework for, like, this Friday. We're going to have a test on chapter 8 and how you'll submit your homework for that. So let me just bring you to today's folder. the outline for the day today. I'll show you briefly. You're going to watch a little crash test, car crash DVD, have a little work time. So you'll see there's all be embedded in there will be the places for you to turn in homework, office hours, etc. Okay. The embedded code will be up here as well, but I'm actually recording this on Monday afternoon. So here's the video for the crash test, car crash review, Chapter 8 textbook, workbook assignment. Here's where you can submit those experiments 11, 12, and 13. Also, any other late labs previous to those you can turn in here. Missing homework from those other tests that you haven't taken yet, you can turn that in here as well. So that's kind of what how that's going to work. And then as you see each day this week, Wednesday, Thursday, Friday, there's a folder for the day's activities. So feel free to look around through that. And what I want to do to finish up for this little video this morning is just to do a quick review of what we did just prior to school getting shut down so abruptly. We had started on Thursday, we had started momentum after the test. So I just want to review a little bit with that. Remember momentum, the symbol for momentum is P. Not exactly sure why it's P, but you can research that if you'd like. But so P is mass times velocity, or momentum is mass times velocity. So an object has to have mass and it has to be moving in order for it to have momentum. We also talked about if we want to change an object's momentum, that's the delta. If we want to change an object's momentum, we have to apply a force to it over a certain amount of time. This, if you remember, was called an impulse. So we have to apply an impulse on an object if we are to change its momentum. And if you remember, I gave you a bunch of examples about, like, I'll use a simple example of the airbag in a car. The purpose of it is to increase the amount of time that it takes for your body to come to rest, for this momentum to change, so that the force of impact on your body is small. And we talked about other examples would be cushioned running shoes, or bending your knees when you land off of coming off of a stairs or something like that. It increases your time, so it lowers your force. Okay. The other part of the material that we covered was conservation of momentum. And if you remember, in conservation of momentum, the total amount of momentum that you have before the two objects collide is equal to the total amount of momentum that you have after they collide. So we broke that down into two different types of collisions: elastic collisions, or paraphrased as bouncing collisions. And we wrote it out as the momentum of object 1, mass times velocity, plus the momentum of object 2, mass times velocity. Here's the collision. Equal sign means they collide. This is before. Hopefully these notes look familiar to you. And over here is the after part, after the collision. So again, we rewrite them. M1, V1, we put a little asterisk or a star next to it. And then object 2, after the collision, put a little star next to that. So a typical example of a bouncing collision would be billiards, playing pool. And this would be the cue ball or the 8 ball. And a typical test question would be, or homework question would be, what is the new velocity of the 8 ball after the collision? Something to that effect. Okay? So if they don't bounce but they stick together, we call that inelastic, or sticking. And it's really not that much different. The before side, the left side of the equal sign, it's exactly the same. But after, since they stuck together, we take their combined masses and we multiply it by the new velocity of the two objects stuck together. You could think of it as two train cars that are about to collide in the railroad yard, two football players on the football field colliding. And if you remember in that football example that I gave in class, if one of the athletes is moving in the opposite direction, we note that on our equation by saying one of their velocities is negative. So we could say football player number 1 is moving to the right, and football player number 2 is moving to the left. And then again, they might say, what happens to the two objects after the collision? Do they continue moving forward, or do they get bounced backward? And that all determines by whether or not your answer is positive or if your answer is negative. If your answer is negative, it goes to the left. If your answer is positive, it goes to the right. So that's a little bit of a review of what we did the couple days prior to departing before school was shut down. Hopefully that triggers a little memory, and you can refer that to your notes and take your time and go through. We're starting kind of slow. This week is kind of just reviewing and getting caught up, and a couple little new content things each day, but otherwise, yeah, hopefully, if you have any questions, visit me during the office hours today and ask questions, and I'll go over in more detail whatever you need. Thanks. Good to be back in front of you. Hope you're doing well.